Mr. Pelton. This is Algebra 2, Chapter 5, Section 6. This is Part 3 of the video for inverses of functions. So, if you have a function and you graph it, the question is, does it have an inverse function, or we need to restrict the domain somehow? So we did that algebraically in the previous section. But you can tell by looking at the original if it has an inverse function or not, or if you need to limit the domain, by doing what's called the horizontal line test, which has the same premise as the vertical line test. The vertical line test tells you if it is a function. The horizontal line test tells you if it has an inverse function. And the premise is you draw the horizontal line. If it intersects more than once, then it doesn't have an inverse function. If it is only once, then you're good. So in this case is A, B, C, D, E. Take a look for yourself. Pause for a second. Take a look. Figure out which ones do not have inverse functions. So B does not pass the horizontal line test. So there is no inverse function that exists. Okay. C also fails. It hits 3 times. This hits twice. This hits 3 times. So no inverse function exists. And all the other ones pass, because no matter where you draw the horizontal line, it's going to pass. Okay? Thus, you would not need to do any domain restrictions for it to have an inverse that exists. Pause the video, try the student problems. Okay, for the student problems, the first one, which is an absolute value, that has a problem. So no inverse function exists without domain restrictions. The third one, D, no inverse exists without domain restrictions. And the last one, E, also fails. So there is no inverse that exists unless you have domain restrictions. Okay, page 6. So if you have two functions, what's a quick and easy way to determine if they are actually inverses of each other? Well, the reality is you're switching the variables x and y, so they should be symmetrical along that line y equals x. So if you switch the variables, if you put one inside the other, they should cancel out. So do the composite function, and you should just get the x that's left over because of the fact you're just switching the values. They just cancel each other out, which is the point of an inverse function. If you're a computer programmer, one function undoes the other, regardless of which order you do it in. G versus F, F versus G. In this book, they use G to signify it's the inverse function. Okay, so let's try some examples here. So we'll do f of g of x here, and g of f of x here. So in the first one we use f, which is 3x plus 2. And the second one is g, which is x minus 2 over 3. So essentially here we're plugging in g, so that's x minus 2 over 3. And here we're plugging in f, which is 3x plus 2. So essentially, make that a little less sloppy there. The 3's cancel. I'm left with x minus 2 plus 2, which is just x. So that one worked. Everything canceled. Here I get 3x over 3, which cancels. So that one also works. So that means they are, so f of x and g of x are inverses of each other. It's not that one is an inverse, they're just inverses of each other, depending on which way you want to go to do or undo something. So try the same thing here. F of g of x and g of f of x. So here we'll use f, which is 2x minus 1, and then here's g, which is x minus 1 over 4. So we're going to plug in g, which is x minus 1 over 4. We're going to plug in f, which is 2x minus 1. Well, that's going to leave me with x minus 1 over 2, because that's a half, right? But that doesn't cancel. And then here I'm going to be left with 2x minus 2 over 4, which also doesn't cancel. So therefore here, f of x and g of x are not inverses of each other. So they would not undo each other. So if you're doing a program to do coupons or discounts, it would not undo the discount as a result, or undo the coupon, whatever the case may be. All right, try the student problems. Okay, let's try these. So we have f of g of x and g of f of x. So f is 4x plus 7, and g is x minus 7 over 4. So we're going to plug in g, which is x minus 7 over 4, and we're going to plug in f, which is 4x plus 7. So here, those cancel. We're left with x minus 7 plus 7, which is x. That worked. Check mark. And then here we have 4x over 4x, because the 7 and minus 7 cancel. So we're left with, I'm sorry, x. There's no x at the bottom. That's a typo on my part. I'm sorry. So that one also worked. So therefore, again, f of x and g of x are inverses of each other. So either of them will undo the other, basically, depending on which way you're doing it. Okay, so let's try these. F of g of x and g of f of x. So f is 2/3 x plus 6, and g of x is 3/2 x minus 6. So on the face of things, it looks like they will cancel each other. But when I plug in g, that's 3/2 x minus 6, and I plug in f, that's 2/3 x plus 6. So we'll distribute. So we get 6 over 6x minus 12/3 plus 6. That's going to be x minus 4 plus 6. Well, that's x plus 2. That did not work. Over here we get distribute 6 over 6x and 18 over 2 minus 6. Simplify, that is x plus 9 minus 6. That's x plus 3. That also did not work. Okay, so they are, so f of x and g of x are not inverses of each other. Therefore, the one will not undo the other. Okay, that is the end of part 3.